Alright, so this is a practice problem to help understand the limiting reactant problems. Okay, so it's an additional aid. So the question I'm giving you in this is that you have aluminum plus chloride produces aluminum chloride. Okay, I've already balanced the chemical equation. Okay, and so you can see that where we have a 2 aluminum for 3 chloride is going to produce 2 aluminum chlorides. What we also notice is that we're starting out with 40.5 grams of aluminum. That's what I'm giving you. I'm also giving you 213 grams of chloride, and I want to know which is the limiting reactant. Okay, so I'm basically just giving you these 2 aluminum and chloride in a beaker, and I want to know which one is going to be the limiting reactant. So the first thing we need to do, as in a lot of these problems, okay, is we need to convert grams to moles. We need to know how much we're starting with. How much are we provided in moles? Okay, so we can set this up and we can take the 40.5 grams of aluminum and convert that to moles. And so we know in 1 mole of aluminum we can get the molar mass from the periodic table, which is 26.98 grams of aluminum. Okay, so grams of aluminum cancel, you're left with moles, and we find that we have 1.50 moles of aluminum. We can also do the same thing for chlorine. We have 213 grams of chloride gas. We know that in 1 mole of chloride gas, we have a total of 71 grams of chloride gas. Our grams of chloride gas cancel, and so we're left with 3.00 moles of chloride gas. So at this point, we're only told what we're given. This is how much we have available. Okay, and so we were given 1.5 moles of aluminum and 3.00 moles of chloride gas. It still doesn't tell us what our limiting reactant is. It just tells us how much we're given. So the next step that we need to do is we need to think about how much we actually need based on the stoichiometry at the top. How much is needed to completely react? Okay, so which one is limiting? So the way you want to do that is you first want to just convert moles of one reactant, so we say reactant number 1, to moles of reactant number 2. Okay, we also want to go ahead and convert the moles of reactant 2 to the moles of reactant 1. This is going to allow us to compare how many moles we need to completely react with the moles that were given of reactant 1 or with the moles of reactant 2. Alright, so I'm going to go ahead and erase a little bit of this, okay, which I just put up here. Alright, so in order to convert the moles of aluminum reactant number 1, we have 1.50 moles of aluminum. We want to convert this to moles of reactant number 2, which is chloride gas. The way we can do this is through stoichiometry, okay? Because what we're told is that for every 2 moles of aluminum, we have 3 moles of chloride gas. And so basically we can just use that stoichiometry to convert to how much chloride gas can we get from 1.5 moles of aluminum. Our moles of aluminum cancel, and what we're left with is we find out we have 2.25 moles of chloride gas that can be produced from starting with 1.5 moles of aluminum. But we also want to be able to compare how many moles of chloride gas we're starting with to how many moles of aluminum we could produce. So in the second step, we can then take 3.00 moles of chloride gas, which is what we started with back over here, which was based on the grams that we had that we were given. Okay, we can then convert that to moles of aluminum, and so what we find is that for 2 moles of aluminum, which is based on the stoichiometry, we have 3 moles of chloride gas. Our moles of chloride gas can cancel, and you're left with 2.00 moles of aluminum. So what I want to point out now is that basically these values, okay, the 2.25 moles of chloride gas and 2.00 moles of aluminum, is what we can theoretically produce if we start with either aluminum or start with chloride. So we can identify which is limiting. If we compare to what we're given, which was back up here, to what we actually have, which is down here. Or I'm sorry, this is what we have versus what we need. So if we start with 1.50 moles of aluminum, which we are given, we can produce a total, or we need a total of 2.25 moles of chloride gas. Okay, we actually have 3.00 moles of chloride gas, so we have excess of what we actually need. Alternatively, if we start with 3.00 moles of chloride gas, we need 2.00 moles of aluminum to completely react with that chloride gas. But we're only given 1.50, so it's limiting. There's not enough to completely react with all of this chloride gas that we're started with. And so from that, we can then determine that aluminum is limiting.